Here we're looking to find the value of the angle theta, where theta is this angle here in the bottom right corner, and we're given three side lengths. So whenever you see three side lengths, that is going to be your cue to use the cosine rule as opposed to the sine rule, because with the sine rule we need sides and then opposite angles, but here we've just got three sides, so I'm just going to have to write the cosine rule out here now, and it is going to look like this. So we have this, and it is going to be in your log table, so you don't need to memorize it, but now we just need to apply it. And so the only thing to watch out for with the cosine rule with your sides is to make sure that you choose the side A correctly, because A is going to be the side opposite the angle that we're looking for, or the angle that we're given. And so A is going to be theta in this case, so that's going to be our angle A. And therefore, to find the side that we use, we need to look across from theta, directly across. I'm going to see that A is going to be 178, so that's going to be the side A. Now if the sides B and C, you can just choose whichever you want. So I've said B is 101 and C is 96, because those are the other two sides in our triangle here. And so now what we need to do is plug all these numbers in, and we're going to get an expression with cos theta in it. And so that's going to look like this. And now so we have this expression, and we just need to simplify it a bit. And so now we squared out our numbers, and I realise they're quite large numbers, but luckily there's going to be no decimal points or anything like that when you square these. But now we just need to move on to dealing with this kind of expression with cos theta. So we have minus 2 times 101 times 96. And so I'm just going to combine all those three numbers, and that is going to give us minus 19,392 times cos theta. So now most of the hard work is done, and we just need to rearrange this. So the first thing I'm going to do is just take over these two numbers, 10,000 roughly and 9,000, over to the left hand side. So I'm going to subtract both of them from the right hand side, and then after that we're going to be dividing across by the number in front of cos theta. And so now our expression is going to look like this. So it's beginning to take shape a little bit. We've just got a number on the left hand side, and then this cos theta times minus 19,000 on the right hand side. And so what I'm going to do is I'm going to rewrite this so the cos theta is on the left hand side. We're just going to divide across by that 19,000 now, and we're going to end up with a fraction on the right. So again, just dividing across by minus 19,392. And so our very last step now is going to be to get the cos inverse of this. So theta is going to be the cos inverse of this fraction. And just one thing to note is that we need to make sure we include our minus sign. So you can see we had minus 19,000 over on the right, then we brought that over into the fraction. And it makes sense that this is a negative number inside our bracket here for our fraction, because as we can see in our question, theta is going to be an obtuse angle. So wherever theta is kind of obtuse, we would expect the cos of theta to be a negative number. And so that's kind of just a side note, just in case you think it looks weird. But now we can actually find our answer here. And our answer is going to be 129.24, which rounded to the nearest degree is just going to be 129 degrees. And so that's going to be it for this question.